All right, so a little bit more about nonpolar covalent bonds. Remember, this type of bond occurs when electrons are shared equally. So usually it's going to occur between the same type of atom. So again, think of this as like two twins or two clones playing tug of war. Remember, electronegativity, right, means that they want electrons. So, but if they're the same atom, then they have the same type of electronegativity. And so it's kind of like this give here of these two dogs playing tug of war. Not one of them is pulling more than the other, right? Think one is a hydrogen and the other is a hydrogen pulling an electron. They're both have the same amount of pull, right? So no one has more pull than the other. So, like I said, two clones playing tug of war, they're identical in every single way, and not one atom has more pull than the other, so they are shared equally. So, an example of that is going to be like oxygen, two oxygen atoms together. And again, because they're the same exact atom, they both have the same amount of electronegativity. So, they're both pulling the electron at the same amount, right? So, not one of them is pulling it like in an ionic bond, where one of them just basically takes the electron from the other one. And one of them, in that case, is stronger. In this case, they both have the same amount of electronegativity. Right. So, but now you have polar covalent. So that last one was nonpolar. Remember, nonpolar means the same, whereas polar means different, right, or opposite. In this case, you have two different atoms, right? With one will have more electronegativity, so it's going to have more pull than the other. So this type occurs when electrons are shared unequally. Think of it like two people with mismatched strength playing tug of war, or the two dogs below fighting over the bone, right? You see the dog, the hydrogen dog, he kind of donate. So he still has a bone in his mouth, which means they're kind of sharing it. But in this case, they're not sharing it equally, right? The gray dog is more electronegative, and so it has more pull. So you see, it has more of the bones, right? That's kind of like the bones are like the electrons. The gray dog, the fluorine dog, he actually, and fluorine is a type of element, he actually has more electronegativity. So it pulls more than the other one. Another example of this is H2O, right? So here you see H2O. And what you see here is that these are not completely negative and completely positive. Right here, it shows you positive and then here negative, but this is more accurate right here. This symbol right here means slightly. Right, so it's saying that this is slightly negative, the oxygens, and the hydrogens are slightly, so this again means slightly, are slightly positive. Right, and all that, the reason why that is because electrons, oxygens are more electronegative. Right, so the electrons spend most of their time around here, they're just going around here, and they spend most of their time here, and because electrons are negative and they're spending most of their time here, these oxygens become slightly negative. And because oxygen only every once in a while will like circle here, orbit here, every once in a while here, but then spends most of its time here, then the hydrogens become slightly positive because again, the electrons are negative, and if they're not spending much time here, then these kind of stay slightly positive, and because they're spending all the time in the oxygen, which are more electronegative, it becomes slightly negative. Right? Remember, electrons are negative, so the oxygen, as you see here, is slightly negative. Um, spend most of their time here, and because they don't spend much time at the hydrogen, these become slightly positive. All right, so, and this is why two water molecules will stick to each other, because the negative part of one water molecule will attach itself to the positive part of another one, right? And so on. With this one here, this positive hydrogen will attach itself to the negative oxygen. And so that's why water molecules puddle together in little puddles, is because they attract each other.